Hey Jeffrey. Oh Jeffrey, how's it going?
Everything good. Okay, I saw
Excellent.
your report. When it is due? Tomorrow?
Yeah, I'm turning it in tomorrow, like the typed up version.
Okay, okay. I'm going to email you because some of the actually it's okay. It's good, but one or two places we have to modify a little bit. Okay,
Okay.
I'm going to just okay. Let's see this one. Okay, you already sent me the book and the questions.
Mm-hmm.
Let's try some of the questions. You already have that those questions because you told me 1.3, 1.7. Am I right?
Yes. Yeah, I'm just looking at. I'm gonna turn to the back of my book now and check them out. So for chapter one.
Is it the same? Let me see like this one. The
Yep.
questions
Uh,
1.3 is the
one
same?
1.3. Give an example of. Yes. Yes.
The
Yep.
same thing. Okay.
Exactly.
Okay, so give an example of a homogeneous mixture and an example of a heterogeneous mixture. So homogeneous mixture, first of all, any mixture of gases is always homogeneous. So even you can say air. Air is an example of homogeneous mixture
Okay.
because the two main gases, nitrogen and oxygen, and plus other gases in small quantity like carbon dioxide and other inert gases, but these are the two main gases. So this is air is the example of homogeneous mixture. Also you can say solution of salt and water.
Mm-hmm. Mm-hmm.
Solution of salt and water. Because salt is completely soluble in water, and if you make the solution, it will become homogeneous. So these two are the examples of, you can say, homogeneous mixture.
Got it.
Now, what is the difference between homogeneous and heterogeneous mixture?
The
For
difference.
example, if
Oh, never mind.
what is the difference?
Like homogeneous would be it's consistent all throughout, whereas like heterogeneous mixture would be kind of inconsistent, and we
Yes.
could think of like a cookie, chocolate chip
Okay.
cookie. Maybe
Yeah, you're right.
one bite
Yeah.
has like three chips. You know.
Yes. Yeah, you're right. 100% you're right. So look here. This is I'm taking salt solution. Aqueous solution of salt, which is homogeneous. Suppose if I analyze this portion and I'm getting 5% salt, this is 5%, suppose mass by volume or solution, or maybe mass by mass, and 95% water. Now I'm taking another portion from the bottom.
Mm-hmm.
If it is properly mixed, I will get the same result, 5% by and 95% water. So throughout the mixture, the composition remains same.
Okay. Composition.
So then it is called like the composition of the components remains same. It's not like at some place you will get like a more salty water, the other place less salty water. No. If
Right.
it's
Right.
just completely mixed, it's going to be homogeneous. It's clear?
Got it. Yes.
So, and the same thing is air. Air is another example of uh, homogeneous mixture consists of nitrogen gas, oxygen gas, plus other gases like traces of carbon dioxide, inert gases, etc. So this is all the
Got it.
mixture of gases are always homogeneous. Now they're also asking heterogeneous. Heterogeneous means like your heterogeneous mixture. Even you can say your cookie is also heterogeneous mixture.
Mm-hmm. Mm-hmm.
And similarly, if I take salt, if I will take salt and mix it with flour,
Oh yes. Yep.
so it's not going to be like at one place maybe more salt, other place will be less salt. Okay,
Mm-hmm.
maybe
Mm-hmm.
1% salt here, maybe here it is 2%. So The composition of the component is not same. So it's like heterogeneous mixture. Is it clear?
Yes.
Okay, now the next is question is 1.7.
Yeah.
Okay, read this question 1.7.
Yep, we have, do these statements describe chemical or physical properties? We have A.
Okay, do this statement describe chemical or physical property? Physical properties are like melting point, boiling point, even the color, if some color is there. So in this case, oxygen gas supports combustion. Combustion is like a burning process, and it's a chemical reaction thing. So whenever there is some reaction type things, chemical reaction type things, it is chemical property.
Got it.
So oxygen gas supports combustion, it is chemical property.
Chemical property.
Fertilizers helps to increase agriculture production. Okay, fertilizer help to increase agriculture production. Now it looks like it's going to be chemical properties because maybe they are producing something which enhance the production.
Yes.
But I have to double check this one. Water boils below 100 degrees Celsius.
That'll
Water
be,
boils
is that physical? Because it's
physical
boiling?
on top of, yes, it's because it depends on the vapor pressure, so it's a physical property, boiling thing. Lead is denser than aluminum. What do you think?
Physical property.
Physical property, because how heavy, how lighter, is also physical. Uranium is a radioactive element.
Is this, is that a chemical change? Or no, chemical property? No?
Actually, we don't see chemical property, and is a radioactive element because it is emitting something. And normally when it is emitting something, it changes into some other element. So with that respect, I can't say, I have to double check this one, because uranium is not exactly, but we can say radioactive element because it is keep emitting something. But basically when they emit something, they also produce some new material, which is also not a chemical reaction. So this one is like a nuclear properties, but because they are asking, so basically there is like a nuclear property, but I have to check this one. Under what? I'm going to double check this one, okay?
Okay. Got it.
Because according to the definition, they don't come under both of them.
Got it.
Or of course it do not comes because radioactive elements, it is changing, giving and making new element, new substance. So we can, to some extent, we can see chemical, but we have to double check.
Got it.
1.8, what? 1.9.
9. Yep. It says which of these properties are intensive and which are extensive. And
9. Which of these properties are intensive and which are extensive? Now remember, extensive property depends on the quantity, and intensive property is independent of the quantity. If you make it half and the value also change, it is extensive property. So suppose you have a rod, iron rod. If you cut from the middle, the length will become half or not?
yes. If you
So
yes, the length will be shorter.
Shorter. So you become half quantity, right?
Half quantity, yep.
So that's like a extensive property. Now volume. If you take a glass of water and transfer into some other container, so volume is going to reduce or remain same?
It'll reduce if there was some left over or spilled, things like that, yeah?
And also if you take less gram, for example, if you are taking 50 grams of water, maybe it's going to be, assuming the density is 50 milliliter volume. If I take half of this quantity, I will get 25 ml. So making the quantity half, also reducing the volume into half. So it depends on the quantity, depends on the amount. It's clear?
Yes. Did at first
Similarly,
did you say intensive is independent?
yes,
Okay.
intensive is independent of
Okay.
the quantity or mass.
Got it.
And similarly, if you take, like, for example, for this volume, suppose if I take gas, 1 mole of gas at STP, standard temperature pressure, what is the volume?
Hold on. Repeat that. I was just writing something down. I'm
The
sorry.
volume of 1 mole of gas
Yep.
at standard temperature and pressure. It is more called molar volume, 22.4 liters.
Okay.
Okay, if I take half mole, the volume will also become half.
So it'd be
So
like 11.1 or
11.2.
11.2. Okay.
Yeah. So it's extensive or intensive?
Extensive.
Extensive. So volume is also extensive, length is. What about temperature?
Intensive. Is it?
Intensive. Because, yes, you're right. Why? Because temperature is the average measure of the average kinetic energy. Suppose this whole rod, glass rod, is at 100 degrees Celsius. If I cut from piece, still they are going to be 100, am I right?
Yes.
So this is going to be, temperature is not going to change by reducing the quantity.
Oh, okay.
Because, okay. And also because it's a measure of average kinetic energy. So average is going to remain same. What about area?
Area.
Yes.
Length time. That's gonna depend on the length times the height. Yeah.
Okay, so let's take like this one.
Extensive.
Suppose I have a gold piece, and this is like here. I have
Extensive.
this gold piece, and now area is length into width, and what? I am making
Yes.
it half. So area is also going to change or not?
Yes.
Area is also going to change, because when you are changing the length, you are changing the width, the area is also going to change. And also remember, because the density of gold is fixed, if you take less quantity of gold, suppose you are taking 10 gram gold, its area is going to be different than 20 gram, right? Suppose
Yes.
both of them are in the same shape. So it also, like, area is quantity dependent. It's clear?
Got it. Extensive. Yep. Yes, sir.
Extensive. What about the next? What is the next one? Length, volume, temperature.
Yep.
Oh, we are doing 1.9, am I right?
Yes.
Okay, so length is extensive, volume is extensive, the
Temperature.
mass is also extensive.
Yeah.
Because if you are taking 20 gram of some substance, if you divide into half, the mass is going to change. Only the temperature is intensive. What about in the 1.10?
Yeah. So, yeah, you mentioned area, so that one's extensive, and then color. Would color be intensive or?
Intensive, because if you have a gold, it's a golden color. If you make it half, it still remains golden in color. So do not depends on quantity. What about density?
Intensive.
Intensive. Density is also intensive.
Whether we
about
have.
boiling?
Oh, sorry.
Okay, ask the question. Because density, why the density is intensive?
It's
For example, let's take water. Water has a density of 1 gram. Suppose I have 100 ml volume and the quantity is 100 grams. Density is mass by volume. So I'm taking 100 ml divided by 100 gram. I am getting this is 100 gram, this is 100 ml. I will get 1 gram per ml density. Now suppose I am taking half quantity of the water. Now I have 50 gram. But the volume is also going to be half, 50 ml. What you will get?
density is
Again,
still 1.
Hmm. What will be the density now?
1 gram per ml.
The same thing. So by reducing the quantity, the density do not change. So it's intensive property. It's clear?
Yes. Yep.
What about boiling and melting point?
Say again, volume of...
No, a boiling point.
Oh,
Boiling temperature, melting temperature.
Boiling point is a physical property, yeah? Or that's...
Yes.
That's in...
No, it's a physical property, but intensive or extensive?
I'm thinking... Is it intensive? No, because it can change. Yeah.
Because if you are taking 100 grams water, its boiling point is 100. If you take 10 gram water, its also boiling point is 100. So it do not depends on the quantity.
So it's intensive.
So it's extensive.
Extensive.
Oh, sorry. It's intensive. Sorry.
Intensive. Okay.
Because it do not depend on quantity. Okay, now let's go to the question number 1.11. We already no 1.11.
Yep, classify each of these substances as element or compound. And so A is hydrogen. So hydrogen, we could think of H2, but that's
formula is H2. Yes.
H2. That's it'd be an element though, yeah, or no?
Element. Yes, because even it's a molecule, but both atoms are the same. What about water?
Water is a compound, H2O.
H2O, hydrogen and oxygen. What about gold?
Element.
What about sugar?
And sugar is a compound.
Yes, because it contains carbon, hydrogen, oxygen.
Yep.
Anything which contains more than one element, like a substance, more than one element, is a compound. Now, what about question number 17?
17. A lead sphere has a mass of 1.20 times 10 to the 4 gram, and its volume is 1.05 times 10 to the 3 centimeters cubed.
Okay.
So that means
calculate the density of the lead. Okay.
Yep.
The formula for density is mass over volume. Density is the mass over volume. Now, what is the mass? Grams is given here. 1.20 times 10 to the power 4 gram. What is the volume given here is 1.05 times 10 to the power 3 centimeter cube. And remember, centimeter cube and milliliter is the same thing.
Got it. I'm getting with 3 sig figs.
So both of them are 3 sig. So we keep 3.
I'm getting 11.4 grams per centimeter cubed. Yep.
Okay, just a second. 1.05 exponent 3. What is your answer? 11.4? 4. You are right. Keeping 3 significant figure. Grams per centimeter cube or per ml, that's the density.
Yep.
Is clear?
Yes, sir.
Okay, now let's go to the 1.21.
1.21. We got some scientific notation.
Where is one? Oh, it's here.
Yep.
Express the numbers in scientific notation. This is a standard form of number. Now look here, decimal is here, am I right?
Yes.
In scientific notation, we put the decimal after the first non-zero number. So what is the first non-zero number here?
2.
So put the decimal after 2. 2.7 is going to be 2.7. And now, how many positions you are moving the decimal? Because we have 1, 2, 3, 4, 5, 6, 7. So 7 zeros and 1, we are bringing it here. So you are moving the decimal to the right. How many position? I think 8, am I right?
Yeah, 3, 4.
3,
Yeah.
8, 6, 1, 7, and 2 like 8.
Mm-hmm.
So now we have to look like 8 position. You are moving the decimal to the right. Whenever you move the decimal to the right, it's -8. And also another, suppose if I forget right or left, but I know that this number is less than 1. Am I right?
Less than 1, yep.
If it is less than 1, the power is going to be negative. If it is more than 1, power is going to be positive. So this definitely is going to be -8.
Got it.
What about this one?
356 is larger than 1, so we would place the decimal in between the 3 and the 5. So
yes, and when there is no decimal, it means the decimal is at the end.
At the end. Yep. Yeah, there's
So
no.
how you are,
So it'd be 3.56 times 10 to the 2 power. To the
right.
positive 2 power.
Yes. Positive we don't write, but it's positive. What about this one?
This one here, we would move the decimal to the right. Since it's this is a number less than 1, we would move it over 1, 2 places to the right. So that it should be 9.6 times 10 to the to the negative 2 power.
Negative 2 power. That's good. Okay. Let's try this one.
8.0 or 802.6. So in scientific notation, it'd be 8.026 times 10 to the 1, 2. So since we're going to the left, it'd be, positive 2. So 8.026 times 10 to the positive 2 power.
And the other thing, if less or more than that, left or right, but other thing is, when you are moving the decimal to the left, and now you are writing 8.026, am I right?
Mm-hmm.
8.026 is less than 802 or greater than?
Less than this original number.
So yes, less than this number. So then you are compensating it by putting positive power. Okay, that's why you are putting 10 to the power 2.
Mm-hmm.
What about this one?
This one here, let me see. We got 1, 2, 3, 4, 5, 6, 7. So it should be 6.21 times 10 to the -7.
You are right.
-7 power.
That's right. Okay, convert these numbers to non-scientific, like its opposite, like a standard form.
Mm-hmm, mm-hmm. So this is 0.23. All right, so we got to the positive 4 power, so it should be.
Now you move because the positive 4 power, move the decimal to the 4 position to the right.
Yep, so it should be 1520. So 1520. Yep.
No, because the power is 4, am I right? So 152, you are moving 2 decimal. Decimal was here. 1 decimal, 2 position. Then I have to put like another 3 position. Am I right?
Yep.
3 position like this one. Oh, sorry, I have to move here from this one. So let me write this. Otherwise, you can do it like this.
15,200.
152, put 40, because 10 to the power 4.
Mm-hmm.
And because after the decimal, you have 2 digits, am I right?
Mm-hmm. Mm-hmm.
So I'm keeping and putting digit here after the decimal. So you are getting like this one only.
Got it.
65200. Okay?
Oh yeah. Yeah, that works.
15200. What about the next one?
B 7.78 times 10 to the -8. Let me see. So I'm gonna do 7 zeros in front of the 7. So it should be
yes, you're
like
right.
7, like 0 point, and then,
And then
7 zeros, and then the 778.
You're right. That's it. Okay, it's clear?
Mm-hmm. Yep.
Expressed, what next question they give? 1.21 we did, 1.23 we also did this one,
Yep.
1.25, okay, 1.25. Now 1.25, let's read this question.
Oh yeah.
Express the answer
To these operations
to
in
these
scientific
operations in
notation.
scientific notation.
Okay.
Okay, because we have a calculator, we can do it easily.
Right.
Okay, but
Yeah.
this one is, okay, first I'm writing like both. First one, I will write this one. How many significant figures? Oh, forget about this, is because we are adding them. Okay, so first I'm converting this into non-scientific number, both of them. I'm doing the A part here. 145.75. The other one is what? If I
2.3.
convert this into, that one is going to be, because 10 to the power minus 1, so 0.23, right?
Yes.
In both cases, because when you are adding or subtracting, you don't see how many significant figures. You only see how many digits after decimal are there.
Mm-hmm.
So how many digits after decimal in the first case?
2.
2. And how many digits after decimal here?
2.
2. So when you are adding them, what you will get? You will retain the 2 digit after decimal. It's going to be what?
145.98.
145.98. But they are saying, what they are saying?
Express these answers in scientific notation.
Scientific notation. So how I can express this in scientific notation?
1.4598 times 10 to the negative. Hold on. No, not the negative. It'd be the positive. To the positive 2 power.
Positive 2. You are right.
And that would be
Clear?
that would be 145.98.
45.98. And because you have to retain 2. You have to answer this one?
Yes. Yeah, I just
Check
got
the
that one.
answer. I want you to check this thing.
Oh yeah. Yeah, the answer in the solution manual, 1.4598 times 10 to the 2.
Oh, because you have the answer, so let's check the other one. Which one I told you have to check. Radioactive something, right?
Yeah, yeah. No, you're right. I think it was around
1.7.
Yep.
Yes, the 1.7E, uranium.
It says chemical property. When uranium undergoes nuclear decay, the products are chemically different substances.
Okay, so nuclear, you can say, that's why I said it can be more closer to the chemical property.
I want to see if it will allow me to. Oh, never mind. If it will allow me to paste something.
Okay.
Oh no, it doesn't.
I think it do not allow you.
Yeah, it does not. Okay. No problem.
Okay. You clear?
Yes. Did you know that the manual that the textbook that I sent you, it should have the solution manual in the back of it. So if like you click off to the side, it should have it should have it.
I think I already downloaded. I haven't checked that one.
Okay. No problem. No problem.
Okay, I'm going to double check that one. So it's clear?
Yes. Yep.
So why they are saying chemical properties? Because after the emission, what happens? It make a new element. Okay. That's why in the past, the chemists were trying to make gold from the mercury. Because mercury is cheaper and gold is expensive. So they are trying to emit something and get that one, gold one.
They weren't successful, right?
That's possible, but the thing is, making gold costs more than the original cost of the gold.
Wow.
Consuming that much energy, the thing is like that. So it's not profitable, like you can say.
Okay. Yeah.
You can make, but not profitable. Okay, what the next question is?
Wow. Uh,
Mm,
well, if we were to stay on 1.25, it's got some like division problems in scientific notation. But
1.25. Yeah, so now you know. Okay, let's try the other one.
so
Try by yourself.
B, so
Mhm.
79,500 divided by let's see, so 2.5 times 10 to the 2 power. So
Okay.
if I'm doing this and I'm punching this into my calculator.
Yeah, in this case, we can use the calculator, no problem. Okay, how many significant figures are here in the
Oh,
first number? Because now it is divide, not the plus minus.
oh, you're right. You're right.
So, how many significant figures?
3,
3. And how many significant figures here?
2.
2. So you have to retain the minimum number of significant figure, like the 2, not the 3. So let's use the calculator. 79500 divided by 2.5 exponent 2, and I am getting 318. Am I right?
Yes.
But I need to keep only 2. So how I will give the answer?
Would it be 3.2 times 10 to the 2? If we
3 point. Yeah, we can do like that one. We can do like 3.2 times 10 to the power.
2, positive 2.
Oh, you're right, because they are saying scientific notation. So in scientific notation, of course, we have to give like this, because now we are keeping. Otherwise, if it is simple, I can keep it like 320.
320, right? Yep.
Yeah. So because now we have 2 significant, and it is the same thing like
Yeah, you're
here
right.
in scientific
You know
notation.
what's strange is about this instructor that I have for this. He
Mm.
he's really confusing the students because he made his own change to the sig fig rules. So like
Mm-hmm.
you see like part B, the 79,500.
Oh.
The way that he's teaching the class is he's teaching the class that this number 79,500 is actually 5 sig figs, and
No.
I was like, it's not 5 sig figs. I was like, it's 3, you know, and
Yes. In case if they write, tell him like this. If I write like 79500 and I put decimal here, now it is 56.
right,
If I put the decimal at the end, then it is 56. Otherwise, it is 3. Okay, check the answer. Answer is if it's saying, but in this case, because anyway the answer is going to 2 digits, so no problem. But
yeah,
it is 3 something. It's not a 5.
no, you're right.
Only when you have a decimal at the end, then it will become 6. 5 of them. So be careful about this one.
Oh yeah, for sure. Yeah, the answer that's in the manual is this one 3.2 times 10 to
Okay.
the 2.
All right. Yeah.
But
Okay.
I'm
Now
not looking
let's.
at it. I'm not looking at it before we solve it. You know, so
Yeah.
I want to make
So
sure
now
that
let's do this one.
7.0 times 10 to the minus 3. So we got subtraction, but it's got oh wow. Well, it's got minus 3 power. So that would be 0.0070 minus, let's see, 0.0008. Yeah, so we would I would retain 4 decimals afterwards. So
Less number of decimal. Because in the first one, 0.007, am I right?
yes,
And the next one is 0.0008. Is it right?
mm-hmm.
So 0.007 minus 0.0008, and I am getting 6.2 minus 3. But I have to retain how many the digit after decimal?
Is it 4?
No, minimum, less. It's 3.
Oh, 3.
Right?
3. No,
Because
yeah, you're right. You're right.
this is 0.007. So 3 digits after decimal. The other one is 0.008. 4 digits after decimal.
Yeah, you're right.
So how you are going to write? The answer I am getting from calculator is this one. So how I am going to write the answer? Because I have to keep 3 digits after decimal in the addition or subtraction. So no problem, just put 6.200. Now I have 3 digits after decimal. Am I right?
Yeah, no, you're right. They're in the manual it's saying in the manual it says this 6.2 times 10 to the minus 3. Like it's only keeping 2 sig figs. It's strange.
Oh, okay. Oh, no, it's also right. It is right. We can also do the same thing. Why? Because if you write this one, 6.2, we don't have to look the significant figures. We have to look that if I convert this into standard form,
Yep.
it is going to 0.062. Am I right?
Yep.
How many digits are after decimal?
Yeah, there we go. 3.
3.
Yeah.
So yes, that's right. You can do like this. Okay?
Got it. Yep.
So that's correct. No problem.
Okay.
Because you have to convert this and check this thing. Okay? Because you need 3 digits after decimal.
Got it.
So otherwise, if we don't do these things and directly using the calculator, how we can do this thing? This is a 10 to the power minus 3 and this is 10 to the power
minus 4.
So just keep the less one, because less one means 3 digits after decimal. This means 4 digits after decimal. Okay. So if we do it without with only on the calculator, still we are getting this one minus 3. So
True.
retain the less one. Okay.
Got it.
Okay. What about question number this one?
Or D. 1.0 times 10 to the 4.
Okay. First, tell me how many digits after decimal here.
We have 1 spot after the decimal.
And we also have 1 after the
Decimal.
decimal. Okay. Even if I write this one as like a standard number, what I will get? 1 and 4 zeros, am I right?
Yes.
2, 3, 4, and putting the decimal here. So I will get
10,000.
only 1 digit after decimal. Okay. So it's no problem. You can just, and this is multiplication, so it's not a plus or minus. So it doesn't matter. Just multiply them and retain the. Luckily, both of them have the same significant figures. How many?
2.
Here?
2.
And also 2. So just keep 2. What is the answer now?
Would this be
This is not a plus.
9.9 times 10 to the 10? Would
10 to
that?
the power 10. You're right.
So, and we could just add those exponents, right? 6 and 4
Excellent.
to
That's
10.
it. That's right.
Got it.
Okay, next question is 1.27. And this one.
Yeah, we got part A. Counting the number of sig figs in each measured quantity. For A, the 4,867 miles is 4 sig figs.
What is the number of significant figures in each of these measured quantities? Okay, 4867.
So it'd be
How many significant figures we see?
4 sig figs.
6.
4 significant
Okay.
digits.
What about this one? Second.
2 sig figs.
What about the next?
5 sig figs.
5. And what about the last?
5. I see 2 sig figs.
2 sig figs. Okay. If your teacher is saying that one, check the answer this one.
Now, yeah, this is very strange. In the in the manual, it says for the answer to D, it says 2, 3, or 4.
Oh, it says all of them.
Yeah, it says 2, 3, or 4.
Book is right. Actually, what happens?
I don't understand that.
No. Normally we say 2. Okay, normally we say according to the rule 2. But actually, what happens? The rule also says that the final zeros, these zeros, they say may or may not be significant. May or may not be significant. So that's why they are saying, generally we say 2, but may or may not be significant. The rule says like the final zeros may be significant, may not be significant.
Okay.
That's why it is taking maybe 2, maybe 3, maybe 4, all of them. That's correct. That's the generally when you read the rule properly, it say all of them.
Okay.
But for common purpose, we take only 2.
Okay.
It's not going to be wrong 2 if I say 2.
Yeah, because that's so, you know what I mean? It's like every chemistry, or the 2 chemistry classes I took before it, that's how we would see that as 2 sig figs.
Yes, normally we say 2, but that if you read the things properly, it say may or may not be. But we don't want to confuse the student. We say just take 2 because 2 is anyway it is right.
Got it.
Okay, but it may be 3, or maybe 1 0 is significant. Maybe both of them is significant. That's possible. For example, suppose depending on the situation, because we don't know that. Suppose the actual number is 20901. So it means, but we are rounding it to 2900. Okay? So this 0 is definitely significant. It was already there in the original number. Only this one we are making 0. So now 3 significant figures. Okay? If it is we are taking like 3, 9, 1, 2. Now even this is not, and we are writing 2900. So we took only 2 significant figures.
Right.
And other we are rounding it to 0. So depending on that.
Okay. Yes.
But for common purpose we take it 2. But in case if they put decimal here at the end, then it means all the zeros become significant.
Got it.
It's clear?
Yes. Yeah, that definitely makes sense. For sure.
Okay, what next?
I forgot to put to mark. He put 1.29 part C. He just marked for part C. For
1.29. Where is that 1.29? Yes, this one. Okay. Because he is taking according to the definition, so you can write all of them. Okay. For the significant for the last one.
Will do.
Okay,
So
carry out these operation as if they were calculation of experimental result, and express each answer in the correct units and with the correct number of significant figures. Okay.
Yes.
Because you are adding them. How you are going to report this answer?
It'll be for part A. It'll be the answer will be reported with just one digit after the decimal point.
Very good. Yeah, but you have to sometimes you have to do the rounding. In sometimes. Let's use the calculator.
Okay.
5.6792 plus 0.6 plus 4.33. My calculator is showing 10.609.
Yes.
092. So what I have to write?
It would be 10.6.
Just 10.6.
10.6.
Yes. Suppose my answer shows 10.68. Then what I will show?
10.7.
10.7. But I have to keep only one digit after the decimal.
Yes,
What
sir.
about the next one? How many digits I have to retain after the decimal?
2.
2, you're right.
Because of the 3.70.
2.91, 0.33. My calculator is giving me the answer 0.7867.
Yes. So we would.
What I would write?
I would write 0.79.
0.79. That's the correct. You're right. And also don't forget the unit. What is the unit in the first case?
Oh yeah, we got grams, or in here we got meters. Meters here.
Meter, yes, gram, and now this one. 4.51 times 3.6666.
Yeah, good. I'm glad that you mentioned those units. I almost forgot about them for this one here. It's important. 4.5 times 3.6.
Now my calculator is showing for the C part 16.536366. What I would write?
Yeah. 16.5 centimeters squared.
You're right. Because I have to retain only 3 significant figures.
Yep.
So 16.5 is okay. And the unit is, because it's a multiplication, centimeter will become centimeter square.
Yeah, I have to make sure I don't make a silly mistake on the exam if he puts that.
So be careful, plus and minus unit is not going to change in multiply.
Yep.
But in multiplication, the unit is going to change.
Got it.
Okay. I will give you one question here. Suppose I am giving you this one. 20.2 divided by 6.8. This is centimeter, this is centimeter. What is the, according to the sig fig rule, what will the answer?
3.0 centimeters.
Because we have to retain how many?
There,
how many?
2 sig figs.
2 only.
2 only.
2 sig figs. So 2.97, if I add, it will become 3.0. You are right. 3.0. So.
Centimeters.
And what is the unit?
Centimeters, yeah? Oh,
no. No unit.
Oh, no units.
Centimeter cancel now.
Got it. Oof.
So there is no unit for this case. Is it clear?
Got it. Okay. Yeah, that's a good one.
Sometimes it becomes dimensionless if you are both top and bottom has the same unit.
Yep.
So only you have to write without unit 3.2. Is it clear?
Yes. I have a question. Say again?
Yeah, sure.
I got a question for you. It's about a pre-lab, and it actually the pre-labs they go ahead, but it relates to calculating molarity of an acid, and you showed me how to get these before, and I was a little mistaken at first. I thought I was going to divide.
Do you have that question right now?
Yeah, I can tell you what it is. It's
Okay. So, just 1 minute. I'm turning light on. Just hold on.
Yeah.
Okay. What's the question?
Can you see that?
Yeah, I can see and I understand. Okay, no problem.
Or it'd be a plus sign.
Oh yeah, that's okay. I understand.
Plus sign right here.
Yeah,
H2SO4 plus 2 NaOH.
Yeah, that's I know. Don't worry about it. Okay, what the question they are asking?
So they were asking us to calculate the molarity of the acid, and they gave us. They said 25.00 milliliter of H2SO4.
25.00 milliliter of H2SO4
was titrated with 0.15 molar NaOH.
0.05 molar.
Or 0.15, not 0.0.
Okay, 0.15. Okay.
And it says 22.85 milliliter of NaOH was needed to reach the endpoint of the titration.
22.85
milliliter.
milliliter. Okay. And they're asking the molarity of the H2SO4. Am I right?
Yes.
Okay, it's very simple. First of all, let's go by simple method like this one. But if they don't want that method, I have another method also, very fast method. So one I'm going like calculating the mole of NaOH. First calculating what? Mole of NaOH in 22.85 ml of 0.15 molar NaOH. How I'm going to calculate this one? You know the molarity formula is number of moles divided by liters.
Yes.
Divided by liter. If they give the volume in liter, either you will change the ml into liter or just put the 1000 at the top. It depends on you. Normally, instead of changing, I put the 1000 here. If I am using the milliliter, I'd use this one, number of moles using the ml instead of milliliter, and this 1000 is to convert milliliter into liter. So because we already have how many? 22.8 ml. Am I right?
Yes.
Oh, sorry. Molar. What is the molarity? Sorry.
0.15 molar.
No, because the molarity is here. So I am writing the molarity, the number of moles, because I have to find out the number of moles. What will be the formula for number of moles? M is the molarity. Rearrange it.
Oh yeah.
Number of moles is equal to molarity times milliliter times 1000. Or you can directly use liter and eliminate the 1000 from denominator.
Got it.
So I'm taking the molarity 0.15 times how many ml we have? 22.8.
Yeah.
And divided by 1000.
Is it?
This 1000 is to convert the milliliter into liter. That's it.
Oh, okay. So we're dividing by 1000. That.
Yes, because I'm using the milliliter directly. That's why I took this one. How much you are getting?
3.4275 times 3. I'm sorry, times 10 to the minus 3 moles.
3.42. And the molarity was two significant figure or one?
The molarity was given in 2 sig figs. 0.15.
So we can use like 3.4 10 to the power minus 3, but let's use this one. 3.4. You can round it to 3.4 if you want. Mole. Okay. Or you can give the answer in the final answer. Use all of them. Okay.
Yes.
Now I'm going to use the moles, because if you look the equation, 1 mole of H2SO4 react with 2 moles of NaOH.
Yeah.
Right?
Yes. Yeah, this is kind of where I was getting tripped up.
Yes. So if it is 3.42 times 10 to the power minus 3, is going to be half of that one. Divided by 2, half. So what you will get? I am getting
1.771375 times 10 to the minus 3.
This is like the number of mole of H2SO4 there during the titration. And this mole of H2SO4 is present in 25 ml of H2SO4. So again we are doing the molarity formula again. Molarity is equal to, I told you, like the number of moles divided by liter, but if I'm taking milliliter, then put the 1000 here. Otherwise, change it into the liter. So I'm putting 1.71 times 10 to the power minus 3 times 1000 divided by 25. And see what you will get.
0.06855.
Because your molarity is given in only two significant figure. Okay, so I'm going to write all of them 0.0684, or I can just report in 0.068 molar. It's clear? Is the answer is this?
It doesn't. It's on a pre-lab, so there's no like solution manual for it. It's actually. I went ahead and I was just looking at like.
Okay, and the other formula, which I can go directly very easily.
Yeah, I was thinking
the other one
was the M1V1, right?
Yes,
but
not the M1V1 because M1V1 but with little modification. H2SO4 plus 2 NaOH, am I right?
Yes.
Gives 2H2O plus Na2SO4. Now in this case you are using 1 of the acid and 2 of the base, am I right?
1 acid, 2 base, yep.
2 base. So I am writing the M1V1. Okay, the other important thing, in order to verify, sometimes we make mistake in writing the formula, so it's better to verify that one. How I verify that one? Because suppose if the concentration is same, if the concentration is, both of them are 0.5 molar, 0.5. Let's take 1 molar. 1 molar, 1 molar. Suppose both of them. Which one is going to use more? NaOH or H2SO4? If the molarity is same.
One acid requires 2
bases.
bases.
So twice, am I right?
Right.
So if concentration is same, suppose the concentration is 1 molar, also for the base is 1 molar. This is acid, this is base, 1 molar. So if I am going to use like 10 ml, 10 ml is going to use 20 ml, but the equation is not correct, am I right? 1 time 10 is 10, 1 time 20 is what?
20.
They are not equal. So I can make them equal. I can divide by 2, by the coefficient of the base. Can you see? What is the coefficient?
2.
This one. So now I can write this formula MAVA. MAVA is equal to MBVB. And dividing by the coefficient, this is like you can say A is the coefficient of acid and B is the coefficient of base. Now I'm writing the same formula which you gave me, like the things. Your molarity of, you told me you use 25.00. According to the equation, the coefficient of acid is 1. Molarity of your base was 0.15. Volume of base, you told me how much you use? 22.85
ml.
22.85
ml.
right?
Yes.
22.85. So let's have a use the 22.85. And according to the equation, balance equation, the coefficient of NaOH is 2. Now calculate the MA. MA is equal to 0.15 times 22.85, and you are sending this to 25 at the bottom like this.
Yep.
Look, we are getting the same answer or different answer?
No, we're getting the same thing. And that's what I did at first, and I wasn't sure if it was correct. So what I did was I uploaded it to a website, and someone tried to solve it, and they did this way incorrectly.
So look here in this case.
I knew it was
all
division.
digits. So I'm getting 0.6855. So I can round it to the 2606855. So rounding it to you, I can say 0.069. Keeping two significant things.
Yep. Yes, sir.
And don't forget the molarity sign. Otherwise, they will either write mole per liter or write capital and uppercase sign.
Got it. And this is
Yeah,
it. This
this
is
is
positively.
yes.
This is it. Yeah.
This A means the coefficient when you're writing the equation. What is the coefficient? If the coefficient is 1, just 1. If it is 2, just put 2 and you will get that.
Got it.
Okay?
Yes, sir. Yeah.
So that's the easiest way to do it.
Man, I knew
Without.
it. I knew that way that you showed me was right. Because someone tried to tell me that that you have to instead of dividing it by 2, that you multiply it by 2, and I was like,
Oh, that's also no. Maybe he's also right. What he's doing, he's multiplying B with this one and A with this one. So it's also same thing. You can also write this formula like, but why I put here? So I know that acid, you know the coefficient of acid. Otherwise, you can write also like this: B MAVA is equal to A MBVB.
No, Jafri, what they tried to, like, it was strange because I even went to like the university. They have a chemistry tutor, so I went over there to see him, and I showed him this question, and he showed me that to solve this is like this. I'm gonna put. He put MA times VA is equal to 2 times MB times molarity the VB. VB. My bad.
VB.
Yeah. So it ended up turning out he put the molarity of the acid. I'm just looking at my notes because even after he showed me, I was like, this doesn't really make sense to me. He put MA is equal to 22.85 times 0.15 times 2 divided by 25, and then the answer came out to 0.27 molar, and I was like, this doesn't sound right to me. You know what I mean?
Right.
I was like, there's something wrong with this. I was like, why are you multiplying by 2? And
no, the thing is, okay, we all become confused when we are using it because we can't keep so many formulas in our mind. Our mind hard drive is also not so big. So what I do is, I use the basic concept and test as soon as I want to use it. I will explain this thing. For example, H2SO4. Okay, how you can test and make the formula right away. And gives 2H2O plus Na2SO4. For example, we know that if I am taking M1V1 is equal to M2V2, okay? V2. The product should be same. But I know that for each mole, 1 mole, I have to use 2 mole of NaOH, right?
Yes.
Twice more. So in this case, if I am taking 1, suppose the molarity is same as I told you.
Yeah, 1.
Molarity is same, 1. So I am taking 1 into V1. If I am taking 10 ml of this one, I know for twice mole I need 20 ml of that one. because I need twice of the mole, and because the molarity is same, so volume should be twice for NaOH. But if I use the formula 1 time 10, 1 time 20, they are not balanced, right?
No, you're right.
So either I can multiply the 2 on the left hand side, or I can divide the 2 here. What I figure out, the best thing is, in order not for only this, just put the coefficient at the bottom of acid and put the coefficient of base at the bottom of base.
Yep.
So that will be more easy. Always remember, you can easily memorize it. Right?
Yeah, no,
A
you're right.
is for acid coefficient, B is for the base coefficient.
Yeah, that's exactly what I was remembering, and I was like, this is. I'm glad I asked you because, yeah, how those other people were incorrect, you know, and I had a feeling that they were, and
the other important thing is, because you already know that this one you are using acid, you are using how much? 25 ml.
25 ml. Yep.
You are using 22 point something. You need so it's not going to be that much. If it's going to be but this is going to be twice.
Yeah. So if I wanted to like match them up, so if I wanted to like, let's see, so we figured that the molarity of the acid was 0.0 like 685. Let me see. 22.85 times 0.15 divided by
okay, let's do the opposite way, whatever we did. Okay, what is the molarity we calculated? Roughly 0.069.
Yes. Yeah, that
after
one.
After rounding. So maybe after rounding, so little bit difference is going to be there.
Yeah.
Let's take 0.069.
Yeah.
Volume is how much?
25. Yeah.
Coefficient is what? 1.
1.
The other one is 0.15.
Yep.
Volume was 22.85. Coefficient was 2. Am I right?
2. Yes. Yep.
Now, both sides are equal or not? If both sides are not equal, it means we are wrong.
Yep. 0.15 times 22.85. Yeah. Yeah. We are right.
Yeah, I'm getting 1.725. A little bit difference is possible because of rounding.
And I'm gonna see what the answer is that he gave me the acid molarity as 0.27 molar, which doesn't make sense.
So this is close to that one.
Yep. No, you're right. Yeah,
Try that one.
Yeah, their molarity is incorrect. So
yes, that's right. A little bit difference is going to be okay, because when you're rounding it, so it gives little difference. But at least 1.7 is okay. It's clear. So any other question?
No, that's all. I'm gonna I should be getting paid in a couple days, and what I'll do is I'll be able to send you some more PayPal, and then we could pick up from where we leave off here. And my exam on this stuff is next Thursday.
Next Thursday.
Is next Thursday, a week from tomorrow.
Like 3rd of October, am I right?
Yes. Yes.
Okay, we can do those, no problem, because these are very simple thing. We can do it very fast with little practice, and then. So you want to stop here?
Yeah, we can stop here. I'm gonna try and like fix up my lab report a little bit, and
okay, let me. I will upload the lab report and little bit tell you something.
Okay.
Hold on, just 1 minute.
Yeah.
Do you have the lab report in your hand right now?
Yes, I have it up on my
Okay.
my Microsoft Word.
Okay. It's uploading, so I'm just going to go directly here. If it takes time. Okay, your lab reports, if you read the introduction,
Mm-hmm.
uh,
Oh yeah.
okay, they already are here. So it's no problem. You can go here. Look here, you read this one. On a paper chromatogram,
Yep.
the solvent front line is the longest possible travel distance. That's not correct.
Okay.
Because it's not a possible, because if you put a more bigger paper, it can travel more distance. If you give more time, it can travel more.
Right.
It is like the distance covered during the same time. When the spot is moving, you are allowing them equal time.
Yeah. Yeah.
Okay. Suppose you are doing the race of the car. You are the car starts from one point. Okay, all of them.
Mm-hmm.
All of them are starting from one point. From here, start race. And now one solvent is moving, covering more distance, fastest car. Some color like spot move here, second position, third position, like this.
Mm-hmm.
The solvent, you can say the pure solvent is the fastest one. Fastest one.
Okay.
So because you are stopping, taking out or stopping the process,
Mm-hmm.
that's why it is stopping here. Otherwise, not the possible distance. We can, if you put a bigger paper, if you give more time, it can travel even more.
True. True that. Yep.
Okay.
Yeah.
So you're seeing that one.
Absolutely.
And the other one is I was looking like here.
That definitely makes sense. For sure.
Okay, that's okay. Now the Polish, this one. Uh, this looks okay, good to me so far.
Okay.
If I read any other thing,
Got it.
okay, so you can just, I'm going to double check this conclusion. I haven't checked that one.
No
I'll
problem.
check the,
I made a couple more edits to it.
okay.
I'll resend this email to you. If you see anything that you think needs some edits, just let me know. And I was checking my bank, and I should be getting paid.
Don't worry about it. You can pay later. It doesn't matter. You already have paid for this.
I
So
should.
don't worry about it.
All right. I
Okay.
should.
So NaCl, 5% NaCl solution is higher affinity. Now this question also, which means the 5% NaCl solution is a higher affinity for the paper chromatography paper than the distilled water. How we know this thing? We don't have. How much distance the NaCl solution has traveled? Because it also depends how much time we are giving them. Okay. So if it is covering less distance,
I can't say that, right?
Yeah, so we can say this thing.
Okay.
Maybe, may not be, okay? But the one thing is, because NaCl is more polar and stationary phase, we are assuming it's a little bit non-polar. So when the difference is more, NaCl can move faster.
Got it. Yeah, I took this out. I just deleted this.
Yeah, so don't say anything which is not certain. Okay?
No, you're right. You're absolutely right, for sure. Got it.
Okay.
Alrighty. Yeah, I'm gonna. I'll resend you my edited one, and yeah, it should be good. All right, Jafri. I greatly appreciate it. I'm gonna keep in touch with you through email, and we'll be able to plan another session.
So this session, don't worry. You already have paid that, so don't worry about it. This session, okay?
All right, thank
already
you.
Have paid.
Thank you, my friend.
And even when you are paying, and if you have like some delays, okay, no problem for me. You can, okay.
You got it. Yeah, I'll always try to pay you at the time that we do it. If
yeah,
I appreciate your understanding.
Because I trust you. When in the beginning I ask to pay, but once the trust built between the student and me, then I don't ask that much.
Got
In
it.
case I ask when if I need something,
Mhm.
and then I ask
For sure.
that one. Okay.
You got it.
Okay.
You got
Okay.
it. Thank you
Take
so
care.
much, Jafri. I really appreciate it. Thank
Okay.
you.
Bye.
Thank you. Have a great evening. Bye bye.
You too. Bye.
Thank you.